And we're back. We're going to still talk about 568C in this next podcast. The last one I left off talking about your categories, your component categories, your cable categories, if you will. We'll review this some more in Chapter 5, just, in another week or so here. The next area they talk about with the 568C is your connector standards. Again, they standardize what connectors will be used. That way, any device I have, my computer, my laptop that I need to plug in, will all have a standard jack, will all use a standard patch cable, plug into a standard outlet. Things would be interchangeable, usable, that sort of thing. So they standardize the use of a standard 8-pin modular connector. We often slangily call it an RJ45 style connector. 4 pairs, 24 gauge UTP provides the cable. All 8 wires are connected to the jack, and I use a system of punch down termination blocks, patch panels, to complete the connection. And all wiring for this is done straight through. In other words, pin 1 on this end is wired to pin 1 on the other end. Pin 1 on this outlet jack is wired to pin 1 on the patch panel in the closet. Everything is straight through. There's no crossing of wire pairs. Um, Here's your modular 8-pin connector that you would typically use on your patch cable that you're used to seeing. That's the style of connector that's used. And the outlet in the wall that I'm plugging my patch cable into would be this type of modular 8-pin outlet jack. We will be terminating these modular 8-pin connectors on our patch cables later this semester. We'll be terminating these modular outlet jacks a little bit later when we do our outlet jack chapter. It says we're allowed to use 2 different types of color codes, wiring patterns for the 8-pin modular connectors, 568A or 568B. These are not the revisions to the standard, okay? These are just the 2 different types of color codes I may use. They are electrically equal, but I reverse wire pairs for the easiest way I explain this: when you need to make a crossover. I can flip-flop wire pairs for crossover. But as far as wiring, I may use the A color code or the B color code as long as I stay consistent in my building. And actually, if I back up real quick and look at this outlet jack, you'll notice that this outlet jack actually has part of the A color code here and part of the B color code here. This jack says, hey, whatever color code you want to use, terminate it and stay with that color code the whole way through your building. And here are the 2 color codes. Here's what your outlet jack would look like: white, green, green, white, orange, blue, white, blue, orange, white, brown, brown kind of thing. And here's a color version if that helps you: the 568A color code, the 568B color code. Now, eventually you're going to need to know these. I do not have a sneaky mnemonic to memorize these, sorry. But usually by terminating these a little bit, you catch on to the color code. One thing I do want to point out, and this often throws people: if you look here in the middle of the outlet, you'll see the white, blue, and blue pair, and then surrounding it on this one, you'll see the orange pair. Well, this comes from the phone days, where these 4 wires here in the middle are used for phone. This would be line 1, and the other line, your second phone line, would be around it. So this is derived right out of the phone system. Well, if you remember, 568 was designed to be a cabling system to handle phone and data. What this means is I can take a regular phone cable, a traditional phone that I use, a phone cable, plug it into this outlet jack right here, and this 568 wiring system will be able to handle it. That's correct. My phone jack, my RJ11 phone jack, could plug into this outlet, and these 4 wires in the middle would be able to handle that phone or that phone call, if you will. That's why when I look at this color code, I see white, green, green, white, orange, blue, white, blue, orange. Okay, it looks odd, but when I think of it in terms of this is phone line number 1 and around it is phone line number 2, it makes a heck of a lot more sense. And I see the same thing when I look at the B color code over here: white, orange, orange, white, green, blue, white, blue, green, white, brown, brown. Again, I see the blues in the middle and the green split around it. And that's why I see up here pair 1, pair 3 is split around it. Pair 1, pair 2 is split around it. That is derived from the phone days, but also so the 568 standard can support phone lines as well as data lines. That's why it's wired that way. That's why your color code looks that way. Here's your modular 8-pin connectors. This would be the RJ jack that you're used to terminating your patch cables. Again, here's your color code. Your A color code: white, green, green, white, orange, blue, white, blue, orange, white, brown, brown, and your B color code starting with white, orange, orange. Eventually, you will need to know these. Again, I don't have a sneaky mnemonic, sorry, but eventually we'll need to know them. And here's another color picture if that helps you too. Pick one of those and use them to start learning your color code. Uses. Okay. As we start looking at the uses for our cabling and the different pieces, well, the first thing they talk about is the horizontal cabling. The horizontal cabling, 4 wire pairs, 24 gauge solid conductor. Okay. Real quickly, horizontal cabling uses solid cabling, just like your electrical wire in your house. The wires installed in the walls of your house for electrical wiring are solid copper conductor. The reason being they have less resistance. The solid copper conductor has less resistance, so therefore it transmits the electricity to the outlet a lot better, if you will, with less resistance. Well, in data cabling, you do the same thing. The cabling installed above the ceiling and in the walls is solid copper conductor. Again, less resistance. It transmits the signal better from the closet or the patch panel out to the outlet on the wall. The downside with that solid copper conductor is it is more fragile. You bend it a whole bunch, it will break. Well, being that it's installed in the walls, nobody should be messing with it for the next 10 or 20 years, if you will. It should be fine. There should be no reason it's going to bend a lot and break. So your horizontal cabling installed in the walls, above the ceiling and in the walls, is solid copper conductor cable. I will show you samples of that when we get to chapter 5. Unshielded 100 ohm. Again, category 5, 6, 7, whatever standard you're using in your building, the horizontal cabling should be that standard. And the length of this is limited at 90 meters or less. 90 meters or less. Horizontal cabling, horizontal cable run is limited at 90 meters or less. Important to know. That's why it's highlighted in yellow. The patch cords on each end, this is the kind of thing you terminated in, probably 120, making a patch cable. 4 pairs, 24 gauge stranded conductor. Okay, again, the copper cable used to make a patch cable is a stranded connector. It's made up of a bunch of smaller pieces of copper twisted together, almost like hairs twisted together into a braid. Those wires twisted together, they are more flexible. They don't break as easy. So again, my patch cable is more flexible, but the downside is there is more resistance. So it is flexible, bending my patch cable around to plug it in, it's not going to break as easily, but there is more resistance to this. That's why you see down here 20% more attenuation is allowed because of that flexibility. Again, unshielded 100 ohms, I'm matching my category. If category 6 horizontal cabling is going in, category 6 patch cables should be used. And these are limited at a maximum of 10 meters, and that is for all patch cables in your system. So roughly 5 meter at where the user is with their computer, and 5 meter in the closet. And if you do higher math now, 90 meter cable run plus 10 meters of patch cable, that's 100 meters. Twisted pair cable can go 100 meters before we need to, regenerate that signal and go across there. So those are the two main pieces of this. And again, if I look at my horizontal cabling system or my cabling structure, the yellow part here is my horizontal cabling. This would be the solid conductor twisted pair cabling installed in the walls. And then the patch cable here, in this case it's red, would be the 5 meter patch cable going from the wall to my computer. And then there would be another one in the closet down here going from the patch panel down to the switch, if you will. Here's another sample. In this case, blue horizontal cabling into my closet. Here's another drawing that I drew to help with this as well, and this might be probably the most handy. Here's my horizontal cabling being terminated in the patch panel, coming out of the closet above the ceiling, down the hall, and into outlets in rooms or offices or classrooms. This horizontal cabling, 90 meters max, solid core conductor wired straight through. This is installed above the ceiling and in the walls, down to outlet jacks. So there's my horizontal cabling, 90 meters max, solid conductor. From my outlet jack on the wall out to the computer, this is where my patch cable comes into play. And that's your 5 meter max stranded conductor for flexibility. And I have that on this end of the cable run, plus I have this over here in the closet from the patch panel down to my switch, if you will. And if I added up 5 meters plus 90 plus 5, there's my 100 meters max for copper twisted pair cabling. Now, that's your horizontal cabling system and all the pieces and some of the details on type of cable and distances. But a lot of times people see this and they're like, okay, all right, but they start getting lost in the whole idea of what's the bigger picture, if you will. So on the next slide, I kind of increase that to show you maybe a two-floor building like we have, at Midtown. I have this for the second floor, and all the outlet jacks on the floor come into this closet and this patch panel down to the switch. Chances are I'm running a fiber line. This is my backbone, my vertical cabling, down to a switch on the first floor. Again, the first floor has its own horizontal cabling coming in the closet. And then these switches get connected into a router and out to the ISP. So I'm probably going to have this structure repeated, on the second floor and the first floor and connected together with my backbone. There's all the pieces of your 568 cabling system pulled together for you. Again, this picture, I spent some time to draw it, but to try to show you all the pieces coming together for our 568 cabling system. And that actually is a good place to stop. When I come back, I'll start moving on to the next cabling systems. But here's your 568 cabling system. And again, we are going to pull cabling. We will terminate the outlets in the room. We will terminate the patch panels in the room, and we will make patch cables. So by the end of the semester, we will have done all these pieces and understand how they are done, why they are done, kind of the ins and outs of doing them, all based on your 568 standard, which again, don't forget the PDF, extra PDF that has in the standard for you. We'll be referring to that as the semester goes on. All right, when I come back, we'll move on to the next structured cabling system.